All right, so yesterday we started to talk about how to identify proportional relationships. And I gave you guys some fractions. I gave you guys some rates. I gave you guys some ratios, which is all three of these. All right, these are all ratios, rates, and fractions. And we used our calculators to figure out if we have equivalent ratios, aka proportional relationships. One way to do this is to just type the ratio into your calculator. 5 divided by 2 is 2.5. 8.5 divided by 3 4/10 is 2.5. Do we have a proportional relationship here? Yes, because the quotient, the unit rate for both of these is 2.5 to 1. Some people even went as far as saying, well, Mr. Meeks, could I divide the numerators? 8.5 divided by 5 and 3.4 divided by 2. And look what happens. Look what you get. 1.7 and 1.7. I even had a person go as far as to say, well, Mr. Meeks, I did 5 divided by 8.5 and I did 2 divided by 3.4. If a ratio is proportional, it doesn't matter how you multiply, you're going to get the same answer. Look at that. What did I do there? Look at that. I cross-multiplied. And notice what I got. 17 and 17. So you could use any of those methods to see if the ratios that are given to you are proportional to each other. You can simply just divide them by themselves. You can divide the numerators, or you can cross-multiply. And if the answers are the same, guess what? You have a proportional relationship. If the answers are different, you do not have a proportional relationship. Sometimes the problems that we get they don't look as clear or as simple as the fraction form. And what I mean is this. Ooh, look at that. That looks nasty. Basically, what we're trying to figure out in this difficult-looking problem is this ratio proportional to this ratio? Well, we got to do some math here. How would I write this first ratio as a fraction? Katie?
3 over 1, 2, 4, 5?
No. Just how would I write the whole thing as a fraction? Cam?
3 over 4.
Yes. 3 over 4/5. And how would I write the second ratio as a fraction? Kennedy?
5/8 over 10.
5/8 divided by 10/12. That is correct. This should look very familiar to you because you just took a test on it. And your class average was 100%. So if you can't do this, then there's a major problem with you. So, keep, change, flip is what your 6th grade teachers taught you. You should use the terminology keep, inverse, reciprocal, and we get 15/4. And then for this ratio, we'll do keep, inverse, reciprocal. 1, 2, 2, 3. So we get 3/4. Are those equal to one another? Yes or no? Does 15/4 equal 3/4? Those are not equal, so our answer would be no. This one was yes. So that's what we discussed yesterday. I gave you a table. You took the y value, divided it by the x value. I gave you a couple sentences, a couple word problems, and we hashed those out. The process is the same. I'm not going to bore you with word problems. As long as you can set them up as a ratio and divide, you'll be able to figure out if you have a proportional relationship or not. So today, I would like to introduce to you the last component of identification. And that has to do with graphs. Cole, I need you to leave your calculator alone, please, and start taking some notes. That would be greatly appreciated. Looking at a graph, how can we tell if the rates, if the ratios are proportional? How can we tell if we have a proportional relationship? There's two key components. If both of these factors are yes and yes, then you have a proportional relationship. Number one, the line must be straight. And number two, the line must start at the origin. Everybody knows that the origin is 0, 0, right? Did you guys know that? Yes or no? You've heard of the origin? Good. So you have to have a straight line, and the line must start at the origin. 0, 0. So here is our graph. There's the y-axis, there's the x-axis, and let's go miles, and let's go hours. Now you might be wondering, Mr. Meeks, why did you only include the first quadrant? Why is there only quadrant 1? Why did you not construct quadrant 2, 3, and 4? What does quadrant 1 have that quadrant 2, 3, and 4 do not have? Or in other words, how about this? What does quadrant 2, 3, and 4 have that quadrant 1 does not have? Joe? Negative numbers. Now, can anybody explain to me how the heck in this world we could go negative 50 miles per hour? Can anybody go negative 50 miles per hour? Can anybody walk negative 12 feet? Can anybody add negative 13 chocolate chips to a cookie? No. Can anybody add to a cake negative 2 cups of water? No. You can't do that. And then I had some smart aleck people in third hour. Well, Mr. Meeks, what about if you walk backwards? It's like, well, if you walk 12 feet backwards, you're walking 12 feet just backwards. Like it's still a positive distance. You're just walking in reverse. You're just walking backwards. I mean, you could walk on your hands. Some people can do that. Some people can, walk on their hands for 12 feet. Some people do the wheelbarrow. You ever see the wheelbarrow? Someone holds your legs and you got to walk on your hands. Well, if you do that for 12 feet, you went a positive distance. And then if you turn around and came back, guess what? You still went a positive distance. Well, what about Mr. Meeks? Somebody asked me this third hour. What about if you fly to Boston and then you fly back? Aren't you coming? You're going back, so isn't that negative? And I'm like, if you fly 600 miles to Boston, you're going to fly 600 miles back to Detroit. It's a positive distance. You can't go back in time. Unless, obviously, you're Back to the Future, Marty McFly, and that movie from the 80s. Ethan?
Khan Academy that says the same stuff that the students were saying. They were on Khan Academy. There was two robots were walking. One went negative 15. One went 5. What happened to the robot that went negative 15?
Yeah, they probably checked his batteries or something, or plugged them into a power source because can't go negative distance. The reason why I bring that up is for this. This is why I only include the first quadrant. We don't have any negatives. Okay? Does that make sense? So don't freak out when you're like, oh my God, quadrant 1, where's quadrant 2, 3, and 4? Your lines can't go into quadrant 2, 3, and 4. So, there's my graph. Is miles proportional to hours? Yes or no? Let's ask ourselves, do we have a straight line? Yes, we do. Does the line start at the origin? Yes, it does. So is miles proportional to hours? Yes, it is. So for every 50 miles, it takes you 1 hour. For every 100 miles, it's 2 hours. 300 miles, 3 hours. 400 miles, 4 hours. 500 miles, 5 hours. 600 miles, 6 hours. I think I screwed that up. 50 and 1, 100 and 2, 150 and 3, 204. It's got to be constant. Have you ever heard that phrase? Constant? Does anybody know what constant means? Doesn't change. Yeah. 7.272727272727272727272727272727. That's constant. Doesn't change. All right, let's take a look at this graph. So we have cost in dollars, and we have items. So the question is going to be, is cost proportional to items? So we have to ask ourselves, do we have a straight line? Yes, we do. Does our line start at the origin?
No.
So then you just, no. Nope. Anybody ever boil water before? You guys have boiled water? What's the boiling point? What's the temperature? How hot does the water have to get in order for water to boil? How much is it? Yeah, your necklace broke. Okay. I believe it's 212. I think. Could be wrong. All right, so this is what's going to happen. We're going to be making some mac and cheese. All right? So we heat the water up. We heat it up. We heat it up. We heat it up. It starts to steam a little bit, and then all of a sudden, boom, it starts to boil. And it's boiling, and it's boiling. The noodles are cooking. The noodles are cooking. My noodles are done. So I take the water off the burner, and the water cools, and it cools, and it cools. So this first straight line represents water warming up. This straight line represents the water boiling. Notice the temperature stays the same because water boils at 212. Doesn't get any hotter. And then here's it cooling off. Heating up, boiling, cooling. All three of these are straight lines. It starts at the origin. Is temperature proportional to minutes? Yes or no? No is correct. Why is it no? Adriana? Right, it's not a straight line. Even though each part is straight, the entire line has to be straight. The entire line has to be what's called linear. The entire line has to be constant. Remember yesterday and 2 days ago, Erica has 1 jelly bean. Harriet has 4. 1 to 4, 2 to 8, 3 to 12, 4 to 16, 5 to 20. That's constant. It doesn't change. That line would be straight. This, no way. Any questions about identifying proportions when they're written as fractions, word problems, or in a table? What about a graph? All right. You guys want to get into groups today or no? No? Like partners?
Yes.
Okay, if you want to work alone, you can work alone. If you want to work with one other person, you can work with one other person.